Hallo, it's Dumplet here. Here's an item on geometry. So take a look at the figure here. We have AB equals 3 meters, AC equals 6 meters, and BC equals 7 meters. The blue one is an angle bisector of angle BAC. The red one is a bisector of segment AB. Find the length of AP in centimeters. Now this item came from DAM 2022, an examination that Dumplet has hosted. The link to the PDF file will be in the description. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now this item is a personal favorite of mine because it does involve a lot of the things we've talked about on the channel. So let's try to start with one of the first few Dumplet tutorials. We did mass point geometry here. So now, why do we have to use mass point geometry? If you haven't checked the video yet, click on this card. This will be the tutorial to mass point geometry. Now, some of you guys might be familiar with this because we have two chevrons. So we have two chevrons, a segment that connects a vertex, so in this case A, to any point on the opposite side. Now here we have an angle bisector, and the other one here is a median. So the median and the angle bisector are just special. They are just special cases of the chevrons. So nevertheless, we can still use mass point geometry here. Now let's try to label some masses. So we'll start with the one here because we know that we have a we have a median here. So those two segments must be the same. So let's just say we assign a mass of 1 on A and B. All right. Now, since we have AB to be 3 and AC to be 6, we can actually apply the angle bisector theorem. Now, we're going to use the angle bisector theorem in two ways. Later, we're going to use it for the lengths. Now, we're just going to use it for the ratio. Now, by the angle bisector theorem, AB over BD over here, that should be equal to AC over DC. Now, with this, I should be able to get BD is to DC because 3 over BD would be equal to 6 over DC. So I'll get 3 over 6 is equal to BD over DC. So essentially, BD over DC is 1/2. So BD over DC is 1/2. So that should give us that the mass on C should be 1/2 because BD is to DC is 1/2. All right. So after we have the mass on C, it's really just a matter of addition here because, well, on this point, let's just call this point point E. Now the mass on point E will be 2 because simply 1 plus 1, that gives us 2. Now the mass on D would be 3/2 because 1 plus 1/2 gives 3/2. Now for the mass on P, again, you could use either the red segment or the blue segment, either 2 plus 1/2 or 1 plus 3/2. Both ways, we should be able to get that it's going to be 5/2. All right. Now, from this, actually, we could kind of use some relationship because we want the value of AP. So we could use AP, and I'm going to say we're going to take the relationship AP is to AD because AD is an angle bisector, and there is another theorem that we could apply here. So AP is to AD would be, well, technically AP is to PD. It's going to be 3 is to 2 based on the mass on A and the mass on D, but we want AP is to AD. So essentially just 3 over 5. So it's going to be 3/5. So with this, I will be able to get that AP is 3/5 the length of AD. So let's put this aside. And next, let's try to move on to using the angle bisector theorem. Right. We know that BC is 7. So we could just use the angle bisector theorem here. Now, let me just let BD to be x, and then DC here would have to be 7 minus x because BC, the entire length of BC is 7. All right, by the angle bisector theorem, just from the previous slide over here, we're just going to copy that. AB, which is 3, is to BD, which is now x. That should be equal to AC, which is 6, divided by 7 minus x. Now, let's try to solve for x. Let's do some cross multiplication. 21 minus 3x, that should give us 6x. So we can divide both sides by 3. 7 minus x, that's going to be equal to 2x. 7 would be equal to 3x, so x would be 7/3. Now we can try to solve for the 7 minus 7/3. So 7 minus 7/3, that's going to be 21 over 3 minus 7 over 3. So that's going to give me 14 over 3. So apparently x here would be 7/3, and the 7 minus x here, this would be equal to 14 over 3. All right, now take note that we are kind of interested now in finding AD because we already have a nice relationship for AP and AD. So if I can find AD, I would be able to find AP. Now AD over here is a Chevian, and take a look here. We have this length of 3, this length of 6, the 7/3, the 14 over 3, and the 7. We have a lot of segments here, so we have a lot of lengths here, and that motivates us to use the Stewarts Theorem. So another one of those on the channel. So if you guys haven't watched this video on the Stewarts Theorem, click this card over here. You'll be learning the basics of the Stewarts Theorem and how to set up the triangle for Stewarts Theorem. All right, so the Stewarts Theorem has a very nice formula. Man plus dad is equal to bomb plus sink. So BMB plus CNC. Now it's really just a matter of setting up the triangle. So I'll quickly go through it here. The segment or the Chevian here, you're automatically assign it the length of D. And then the segment that is split into two portions, in this case the 7 over here, we're going to assign it to be the A. Right? We're going to assign it to be A. Next, the two segments, so the two portions that A is split into, it doesn't really matter which is M, which is N. Now let me just assign the left side to be M and the right side here to be N. Now for the last two, for the B and the C, just make sure that B and M, I'm going to say opposite, so quote unquote opposite sides. So B and M should not touch. So B cannot be this one because they have a common vertex of B. So this length of 6, which is, I'm going to say quote unquote opposite to M, that should give us, this should be the B, because this segment and this segment, they do not touch, right? So that's how we assign, or that's how we assign the lengths to the triangle here. Now obviously the opposite to N, or the side that doesn't touch N, this side of 3, that's going to be the remaining letter, which is C, right? Now that we have the letters A, B, C, D, and M and N, we would be able to substitute it into Stewart's theorem. Now just substitute it into the Stewart's theorem and we will be able to get the following. Right, so we have this one. So that's from the Stewart's theorem. You guys could always go back to this figure and check that on your own. All right, moving on. So I highlighted AD squared in red. So all we have to do is just solve for AD squared. Now, to get rid of the fractions, let's try to multiply both sides by 9. So if I multiply both sides by 9 here, I'll get 7 times 14 plus 9 times 7 times AD squared. And this is equal to 6 squared times 7 times 3 plus 3 squared times 14 times another 3. Now, there's a lot of 7s here, so we can cancel one of the 7s out. So I could cancel 7 here, 7 here, 7 here, and the 14 becomes a 2. At least that simplifies my calculations. 7 times 14, that's 98, plus 9AD squared, and equals, all right, equal to 6 squared times 3, that's 108. 3 squared times 2 times 3, that's going to be 54. All right, let's try to solve for AD squared now. Right, 9AD squared. This would be equal to, 9AD squared, So that would be equal to, well, 108 plus 54, that's 162. Subtracting the 98, that should give us 64. So AD squared over here, it's going to be 64 over 9. Now we take the square root. Technically, AD is plus minus 8/3. But again, we're talking about lengths. I don't think we can have a negative one, so we just consider the positive value. So AD is going to be 8/3. All right. AD is 8/3. Now recall this formula. We had AP is 3/5 of AD from the mass point geometry, so assignment of masses. So AP is 3/5 of AD. So AP would be 3/5 of AD, which is 8/3. So apparently we can cancel the 3, and then we're going to get AP is 8/5. Now take note of the unit here. Since the 3, 6, and the 7, and all the other lengths here actually are in, based on the question, it's going to be meters. But take note here, we want AP in centimeters. So going back, we have AP to be 8/5 of a meter, so we have to convert that meters into a cm. So we know that in 1 meter, there's going to be 100 centimeters. Now, just simply get AP is equal to 8/5 times 100 cm. You can cancel the 5 and the 10 over here. 5 and the 10. Sorry, 5 and 100. That's going to be 20. So we're going to get AP is going to be 8 times 20 cm. And 8 times 20, that's going to give us 160 centimeters. And this will be our final answer. Hopefully you guys learned something new from this video. And I'll see you in the next one. Bye-bye.